Right, so I'm gonna stream this in Discord too. So some people might just like randomly join and talk. Yeah, it's not like anyone actually watches these recordings except for me, anyways. So whatever. Um, okay, let's see. So this is just going to be the kind of gold marathon thingy I'm doing in preparation for USACO Gold in December, next December. Okay, here it goes. I'm just going to start at 4:45 so I can kind of time how long these things take. Although I've seen a lot of these problems before, so it's not really like, yeah, see, I already solved this one. So it's not really a virtual, but it's more like, it's more just like practice. So my goal is just resolve or solve every single problem in like new gold. So like after the division realignment. So yeah, I've probably seen most of these before, so I probably already kind of know how to solve them, but I should probably resolve them anyways. Okay. Get the maximum number of points per second. Okay. Um, interesting. Huh. Funk. Okay, let's see. Let's see what play. You think? Wait, okay, so maybe this does depend, like, because I feel like what you should be able to do is you should just do a prefix and then a suffix where the prefix is how many you can win. But then I'm not sure if like if you use up a card, will that screw up things. So I feel like what you can just do is you can just use like the highest cards. And then always have lower cards. Because yeah, you just use like your highest cards and see how many you can win. Right? Because then if you just use up all your highest cards, and your lower cards, like you won't end up using any of your lower cards that you'll use to win. So let's try that. Okay, so how do we implement this? So we need. Um, so how would you tell how many you can win? Okay, so it's just if it's always just highest, how can you tell how many you can win? Make just a set. Just have a set of Bessie's and Elsie's cards, right? Because um, we just need to know if it's possible. So like we don't actually like the cards we actually remove probably won't be the actual cards that would be removed. So let's just do a set. No templates. Fun. Yeah, let's just do fast IO. To be honest, I'm not even sure fast IO works after you do free open, but I never bothered testing. I just put it in anyways. Okay. So actually, what might be easiest if it... Okay, whatever. Like this is gonna be unlocked again anyways. It's not gonna like take that long. So we want the cards go from 1 to 2 ends. So oops. So let's just assume Bessie has all the cards, and then we can remove them as we find out Elsie's cards. Okay, there. So now we have the cards. Now we just need to go. Oh, we need the order of the cards. Put an equal sign there. So we need a prefix and suffix, and then we just find the highest when you add those two together at a certain spot. So for prefix, we want how many can Bessie win if, like, just consider only the first n rounds, and how many can Bessie win if, like, it's just always the higher card wins. And then for the suffix, we do, if you do the last, you can go from round I to round N, and it's low card, how many of them will win. And then I'm pretty sure that, like, those two are, like, independent, since you can just choose the highest. You can always just choose, like the highest cards, and then those won't affect your card choices for the lower cards. So let's try that out. Okay. So how would we do this? Actually, what I might do is do one index. So the first 0 rounds, you can't win anything. And then let's see. You can win the round if... Okay, so here we need auto. Auto's very good. Okay, well, I mean, it's not going to have it. Okay, the difference between upper and lower doesn't matter here. So we just need to check if Bessie has a higher card. If Bessie does have a higher card, so if Bessie has a higher card, then actually, we can just do... and then we're going to need to... Bessie can't play that card again, so we have to erase it. Yeah, I think that's it. And then we do the same thing for suffixes. So for suffix, we'll probably want... Okay, so actually then, this needs to... Oops. You know, I should get into the habit of ending these as 5 and not 1. Okay, so then, all the rounds from n plus 1 to round n is 0 because there's no rounds. No, I don't like this. Let's not do it. just do if I, otherwise just 0. Okay, and then now we start n minus 1 going down. Suffix on equals otherwise just 0. We just do the same thing. Oh, but now we need, okay, so actually now we need to create another, oh, this is interesting. Okay, so first we don't actually need to set else's. So that's actually what we can do. Is let's actually kill these. So I have a set for higher cards and for lower cards. So for low, we actually wanted to go reverse, just because that will make things easier to search. So let's do that. And then for high, we can just not. And then, okay, so actually, we probably do want to put this up here. That way we can. Okay. Oops, we want these to be equal. We're making the same mistakes I made earlier. Okay. Okay, and now we just need to. Oh, right, we need to change these. Let's just. Let me see if I remember how Vim find and replace works. Very cool. Okay. So, okay, lower bound and upper bound still doesn't matter here. So now it's suggested that we could find a lower card. So that's why I swapped the orderings. Okay, so now let's just do. Jeez. Let's try this out. 8, 4, 3. And it's wrong. Okay. Let's. Okay, that's not ideal. What is happening here? Oh, I should maybe actually initialize AI. That would probably be helpful. Let's do that. And it's still wrong. Okay. Oh, right. This should be because we don't want to include the same round twice. So we would want +1. Right. Wait. Okay. So wait, that makes no sense. It should not be going down. Oh, stupid. I'm making so many stupid mistakes right now. Okay. Alright, that's bad. Why is it? Okay, for high, yes. And then no, yeah. And then for like a 7 and a 6 or whatever. Okay, that lines up. And then for low. Watch my entire approach just not work. For low, okay. You could play a lower card, yes. And yeah, you can't. And you could. Okay. This is Big Funkus. Why does this not? Okay, wait, does this work? Oh wait, I'm stupid. I didn't even read the problem correctly. Okay. I just wasted 15 minutes solving a different problem. Um, okay. That was incredibly dumb. Wait, this is just freaking greedy stuff then. Um, okay. This is rather embarrassing. Let's just kill all of that. Wait, so you can just greedy this. You can just, right, because you can just take the first half, and then just play like the highest cards you have for the first half, as long as you match them up correctly, and then play the lowest cards you have for the second half. So we don't even need an AI. Let's just do. We just need. We need to set. And then we'll just match them up as we go. Okay, so this will be a little weird. Okay, implementation for this might be a little messy. Wait, no, we don't even need this. Just do. The searching will just be rather annoying. So, something is happening outside, and I'm not sure what it is. But there's like lots of banging noises, so that's somewhat sus. Okay, let's see. Alright, so we've added. Alright, we need to initialize Bessie. And this is now going to be the third time I've typed out this piece of code. Alright. So let's go first to the high card. So for this, we can just take a pointer or an iterator from the beginning and then just start popping things off since we've sorted already. Oh, so actually for low, we sorted the other way. Honestly, it would be much easier if we just made Bessie a deck. Actually, it'd be easier if we just made all of these decks. So let's just do that. Oh wait, that might be a little annoying. God damn, this is very mean. Okay, no, so let's not make them decks, actually. Let's just... How do we want to do this? So we don't want to make them decks. Let's make... No, because then we will have issues with erasing things. Okay, wait, so what's our end goal? So we just want to start popping up highest number over and over again. Okay, so we'll just have to do an iterator. It'll be rather annoying, but it'll work. Alright, so now we have something pointed at the end. And I can't do our end because I need to erase things. Well, actually, no, I can because we're just erasing from the end anyways. Okay, so then we need... Why is this so ridiculous? Okay, if... Okay, so the value of I.RBegin is less than the value of Bessie begin, then we're good, and we can add to our answer, and then we erase from both. This is really ugly, but it will work. And then we actually will erase high either way, since if it doesn't work, then we can't do anything. So, okay, now these are inside different blocks, so they won't run into each other. Okay, and then we erase the end of gonna see. Yes, that should be. Okay, now the okay, I don't need to start n from or I from n over 2 since we don't use I in here ever. So yay, now we can just erase the beginning like the same normal thing. Okay, there. Okay. This should work. No, it won't. Okay. More on the compiler error. Let's go for the top of this. Oh, whoops. Small brain. Just not reference that. And it's still not working. Okay. Let me just clear this out. So I can just scroll to the top. Okay. Oh my god. Wow, we got the right answer. That is incredibly cool. Why did it print out an output if it crashed? That's somewhat sus. Okay. Well, it works, at least for the sample. And obviously, if it works for the sample, it has to work for everything. Let's see, I did get these points over. Alright. I suppose we can just submit, because like in actual USACO, there's like no penalty if you submit and fail. So just submit. It'd be kind of sus if I got this right and I get it wrong. Golden reference. Ooh, that's promising. Very cool. Okay, we got this right. That's amazing. Let me mark down what time I got this right. I should really make this a table, but I don't know how to do tables in Markdown. So, let's say 5 or 7. Okay, very cool. Let's go to the next problem. Fruit feast. Oh, looks like I never actually finished solving this. All right. Oh, I think this batch of problems. I was on a middle school trip in like 2017 or something, and this was like right after I passed silver. So I think I took this batch of problems. It's just called feast, and I because like we were on a school trip where like you're not allowed to access the internet, so I printed out these 3 problems, and I wanted to print out more, but my dad told me not to because he said I would be able to like do everything, or it would take me like the entire trip, but it did not. It took me like not the entire trip, so I was just busy coding. I actually ended up writing up my solution on paper, which was very, very annoying. So like, don't ever write code on paper if you can avoid it. Okay, let's see. I think this is just like trolley knapsack. So I think I might have solved this in A star. So yeah, there's a lot of problems I solved in A-star which I haven't submitted to USACO since like I didn't need to because like A-star has its own grading system, and also just because wait, okay, let's not send out tie. There's literally 3 numbers. Also just because I'm too lazy to modify everything to use like file IO, even if it's literally just like 2 lines. Okay, let's see how we do this again. Okay, so we can choose A or we can choose B. Okay, let's see. Can we fit 5 times 10 to the 6? Yes, we can, right? Because our max is, I think, 1.6 times 10 to the 7. So this should be enough, but like just barely. Oh, and we only need the decision. We just need to be a Boolean as well. So that will also free up some space. So let's just call it kn for knapsack. So it's max value actually. So 6. Oh yeah, myself is going to be 5. So let's do that. And then okay, it auto initializes as zeros. So someone's getting a call. Very nice. Okay, so auto initializes as false. Okay, so obviously you can get 0 easily. Oh shoot, so we also need we need 2. So we also need to check the state whether we've drunk water or not. So that okay, yeah, I'm gonna just be lazy, and this will take up like a lot of memory, but I don't care. But this way, I can just add A and B to our current value without ever needing to worry about like integer overflow and stuff. Okay, so this way we can do push. We can do push. So we actually don't need to push P since at that point we've already gotten there. So we're just gonna go in O of T time. We're just gonna do K and I. Okay, also, wait, yeah, we need to push the 0. Okay. K and I plus A, 2 equals 2. Alright, this. And technically, KN 0, 1 will also be true, because, like, you could just immediately drink water. It would be pretty stupid, but you could do it. So, let's do that. And then, so we'll just handle all the ones where you drink water afterwards. So if we can't, right, because you can only drink water. Oh, round down, never mind. So wait, okay, actually, if I see, because obviously, like, we don't want to set things that are true if the before wasn't true. Okay, so if it's true, and then you can also do a second one, which will handle the ones where you have water, and that's just one, then one equals 2, and then we don't want any KNI equals 2 because we already drink water. Okay, and actually we can update our answer as we go. So we only ever, oh wait, no, so, yeah, so we'll actually only need to, actually no, it's just so that it looks less sus. No, I'm going to be lazy. Let's just stick it down here. And we can actually just straight up do ans equals I. And then we also need to do a separate check. Right, because including P. Yeah, okay. Okay, that should hopefully work. 6. Why do I keep taking freeze? Okay. Alright, let's just submit. Wait, this is a running time, right? I mean, the memory is kind of sketch, because this is what, like, 1 times 10 to the 7 booleans, I think, right? Yeah. But, yeah, because we add up A or B to T. But I think it should be fine. Yeah, and that's actually 2 times 10 to the 7 booleans. But since it's booleans, I think it should be small enough, because you have like the 256 meg. So it'll use up like a quarter of the memory limit, I believe. Yay, very cool. All right, it's what, 514? Um, all right, very nice. Let's go to the next problem. Oh yeah, and if I finished all of the problems from this contest, which, oh, I remember this problem. This problem's very short. Then I'll just go on to the next and just see how many I can do in like 5 hours. Because like normally I take this 5 hours to do a virtual, but since it's like I'm like prepping for USACO, so I'm just gonna take these 5 hours to do these problems, and then after these 5 hours, I get to go and cram for a chem test tomorrow. So that's fun. Some N and M. So this is, I believe, this is this is basically mainly for memory, but I'm pretty sure it's just DP on you just DP on like the on the thing on the grid, and it's just like I think you need what direction you're facing, and like okay, I should probably actually read the problem because my memory's probably not. Okay, top left, bottom right, same time. Okay, so we just want reds and possible pinks to walk on normally. And orange, and slide until you hit something. So also remove this. This now, funk. Okay, so what we can just do. This is why I read the game Undertale. So what we can just do is we can just keep track of the current location, whether she smells like something or not, and and also which direction she's going in. So yeah. Let's see. Grid. Oh, I said 5, so let's do that. What's this? Feed. We want this to be in. Free open. Free dots. Not. Right. Okay, so we want. Let's also do fast IO just because I believe. Oh yeah, actually, I'm pretty sure fast IO works on Steod. I'm pretty sure fast IO works on files because I remember USACO saying something about how you should do fast IO, and they've used files since like forever. So I'm pretty sure. Okay, let's. Why can I not capitalize things? Okay. Good. And now, okay, so we start at the top. Okay, so we need like, wait, actually, we just need to visit it, I think. We need a visited, which has the location, whether she smells like something, and which direction she's going in. And if the tile's not purple, then we can just set all the directions, since it doesn't matter which direction we were going in. So that'll speed things up maybe a little bit. Although I don't think it should matter. So, should we do visited or should we do this? Because I think you can BFS this actually. It's just a very annoying BFS. Yeah, let's BFS this. So we want pool. I'm just gonna do V since I'm too lazy to type visited over and over, and especially because there's gonna be like 4 different things. Okay, so it's just whether she smells like something and which direction she's going. So actually, let's do direction first and then smell. Are we guaranteed the starting tile's not red? Oh yeah, we are. We are very cool. We are. Okay. we're guaranteed that it's pink. That's very nice. So let's do, so we just want a regular queue. And this is where it'll probably be helpful to write a struct. Let's just do item, generic name, row, column, we need cool, smell, and we need a direction. And actually, since those are flipping still, it's flipping here as well. And I think we should only need constructor when we actually have these things, since we're using it in the queue. So let's just do equals. Okay, and we need the semicolon because structs require semicolons. Okay, item q. Q dot push. Actually, we can just push it as if we were going all the directions, because right now we're not using that. Or actually, we can just not care. We only care about the direction if it's blue. So let's just assume we're going like whatever. Oh, should we need to change? This is neat. Okay, let's do. We need to add the direction. So I just do change R. That's just the way I do it. And let's just do. Down, right, up, left, down, left, up, or down, right, up, left. Okay, there we go. Now we want to go back here. Oops, let me just push. Oh, actually, we can do mplace. Mplace fancy. And we just mplace 0, 0. We don't smell like anything right now, and oh wait, no, we need direction. Okay, let's just do direction 0 because no one cares. And we don't smell like anything. Okay, and oh, we need distance. Okay, let's just add that. And now we need to place another thing. Distance is right now it's just 0. So we haven't gotten anywhere yet. So why we still thinking of Q, per equals font front, and then we can just and now we need to do things. Okay. How do we do this? Alright, so it's either alright, so we can assume that if we're on the tile it's already valid. Because otherwise we would have just never pushed it into the queue in the first spot or in the first place. So right now all we just need to do is if it's purple, then we need to keep going in the direction we're going. Okay, so we need to handle it's either purple or it's not purple. So let's do that. So if it's not purple, then do things. Otherwise, it is purple and do other things. Oh yeah, we also need our our ending condition. Actually, no. What we'll just do is we'll just do this stupid index. So if her.r equals and her.c equals n-1, then we can print out the distance, and we can return. Oops, and if we return 0. And then at the end, if we don't find anything, we'll just we can pause this. We'll just do another one. Okay. So now we need to handle. Okay, we're not in a purple tile. So then what we do? We just go in all the directions. Actually, this is. I'm going to be somewhat lazy here. I'm just going to let's move these to the top. Oops. Oops. Double oops. Can't count. Let's just do a valid where we just check return our. Okay, so first we check bounds. Okay, and we need to make sure it's not visited. And what else? What other issues can there be? And it can't be red. And if it's orange, okay. And if it's, no, sorry, if it's blue, then, so then Bessie smell like. So if okay, so if it's blue and Bessie doesn't smell like anything, that doesn't work. So you need to make sure that's not true either. Okay, very nice. Long chains. I think that's it. Yeah, it should be it. I do appreciate that they make it so that if Bessie's about to slide on a purple tile into into a blue tile, that she doesn't just die. I do appreciate that they actually make it so she just stops. That's very kind. So let's see. Item next is just what. Let's see. Smell. Okay, so actually we can. I'm going to make. Smell. Oh wait, no, that won't work. Yeah, or I could just go full out and just provide the constructor only another item in a direction. No, but that wouldn't work well because then our initial item will be messed up. Okay, so direction is just gonna be I. Smell is going to be if the current one smell. Oh, this also needs to be per.c per.r. Let's fix that real quick. If per.smell or g. Okay, actually, no, I'll do that in the constructor. And then distance is just per.dist plus 1. Okay, this is really bad design, but this is like competitive organization. No one cares if it's bad design. Actually, this is annoying. Okay, let's create a separate. Let's just copy. Just place that. And then we only want this bit. So let's select that. Okay. All right, so and then that way we can check for bounds check. We can check bounds. It's what 2 when we make us another pointers. Okay, if valid. We can just set all the directions actually, since the direction you're going in doesn't matter. Wait, no, yes it does. If the thing you're going to isn't purple, then it doesn't matter. Wow, that is highly annoying. How do I want to do this? If I might just be lazy because it's only what like 4 times as much at most. Yeah, let's just be lazy. Or no, this would also be. I'll just create a set visited, and then push the next. There. Okay. And now we need to handle. Okay, so that should be it for. Okay, so now we just need to handle if it is a purple tile. So if it's a purple tile and the next one is not valid, then we can just go into our regular non-purple tile thingy. So actually, what would be best is if we just actually take this outside of the if. I did not do that right, did I? Let's try that again. There we go. Okay. So what we'll just do is if the current one we're at is purple. Purple is what, 4? Then we do things, and then if it turns out we just go on to the next one, then we'll just continue, and that way we won't have to just put our let's see here. Small. Let's actually put this bit inside. So, this is half object oriented. Okay, not really, but like kind of. Okay, wait, no, we want. It's probably gonna have 50,000 powers. Okay, so put that small. And put this. Alright, and now we need to do what? What do we need to do? If next not valid, then we'll just go with it. Oh, we'll remove Bessie Smell. So we actually want. So what will remove Bessie Smell? Purple. Only purple tiles remove Bessie Smell. So the set visited. Oops. That's not it. Oh no. And then oops, just push and continue. Otherwise, we continue to do it. Okay. So theoretically this will work, but it probably won't. No, we don't. We actually do. Do that in 4, 4, 1, 0, 2, 1. Wait, I can copy paste. That exists. Let's do that. 8. That's not right. Okay, wait, I'll turn on a light before my eyes go blind. Oh, very nice. Looks like the fire station nearby has the Christmas lights on or something, even though it's only November. So, big fun. All right, let's see. When in doubt, let's add a void print. C. What else is there here? Yeah, I'll just remove that when I submit. Okay, let's see. Okay, that lines up. We go to okay, 2. And then we go back. Okay. Oh yeah, I need to set. That would be better. That will make a difference to us, though. I'll just remove some things. Okay. We go 3. Yes, we can. We go 2. 1. 0. Me too. 2. Okay, wait, so down, right, up, left, and then down. Okay. So 3 is actually in the right spot. So the thing is, we should never be able to reach 3-1. Okay, we're not actually ever reaching 3-1. Okay, wait, just to make this a little easier for my brain, I'm just going to change this to a comma. Okay, 0, 3. 0, 2. So we are going in the right direction, but this somehow we just magically. I think what's happening, like 1, 2, 3, 4, 5, 6. Wait, how does this 8? I like where is this 8 even coming from? Okay, at least I can tell. Okay, so we can tell where these things are coming from. It's coming from 1. 1 is going right. So, okay, so all right, let's find 3, 2. Okay, it's coming from down, so it's going up. So we want 2, 2, 2, 2. It's also coming from up. So this one we want 1, 2, 1, 2, 3. 1, 2. Okay. It's coming from 3. Crap. So it's not enough to just check if it's valid. We have to check if it's visitable. Okay, let's define a visitable. And this will just be, we can just copy, so valid is this inside. Okay, so we just need to copy out this bit. Oh, I've all caps lock on. Genius. Okay. Return. And then just kill that. Oh, and it's only visible if it's inside the grid. So let's, and then we can just, now we get 10. Okay. Okay, let's try that. Huh. Did I not free open? Yeah, I did. What? Okay, I evidently screwed up somewhere. I'm missing. Comprehensive. File missing. I mean, I'll output something no matter what, I think. Wait, did I submit? I think I submitted the wrong file. That might be why. Yeah, I'm pretty sure I submitted Feast and not Dream. So let's try that again. Oh, there we go. Okay. And very cool. All right, let's add this in. Oh yeah, I should probably also explain like the solves. This is greedy. And I should really learn how to use Markdown. But I don't know how to use Markdown. I'm not sure if this dash will like be sus or whatever. Fruit Feast was Fruit Feast. Fruit Feast was, you know, and this is Dream at 9:40. So this took me basically an hour to do. And considering that this is supposed to be like the easiest gold contest, like literally, I think this is supposed to be the easiest gold contest because this was right after the division realignment. So I'm not sure if that's good or bad. Bessie's Dream BFS with 4D states. Okay. Okay, so on to January 2016. Let's go. I want to kill this actually. Oops. Nope. Okay, there we go. Let's go back to contests. June 2016. Angry cows. Oh, I remember angry cows. Okay. Let's see. Yeah, this is kind of the issue with this is I've seen some of these problems before, so it's like kind of sus in the way that I like don't really get to approach this fully. Okay, let's just first one. Angry cows, basically cows. The original screenshot. One-dimensional scene. Okay. This thing set of just the power up. So all we need is the power. I would think this is easily binary searchable. Is this binary searchable? I remember something in A-star about double binary search when we were doing this, which is very much influencing my thought process right now.
Okay, so let's go with the binary search on the answer idea, right? So if you're given the radius of the initial cow, can you tell whether it'll work or not? So how would we do that? This actually requires thinking, and I dislike that. Thinking is annoying. Um,
Let's see. I think, wait, can you pre-calculate like a like if you want to explode all the hay bales to the left of this hay bale, then this is like the power that you need to detonate this hay bale at to make that work, and then you can pre-calculate that, and then wait, I'm not even sure this requires binary search. Then you can just pre-calculate that, and then you just take and then you just find the smallest of the two maxes of those. Oh, and then you get into the issue where you might need to explode in the middle of something. So then you would need to calculate also, um, like what would be if you did the middle of those two, and that would be very annoying. So, but I think if you can calculate those two arrays, you should be good. Because then so then say because either you explode at the middle of two. Is it ever optimal to explode not at the middle? Like it's either is it optimal to either always explode at a hay bale or in the middle between two hay bales? Is it ever optimal to explode somewhere else? So I feel like you might not necessarily want to do. Let's see. I really kind of want to grab some ice cream right now, but I probably shouldn't do that. Both because I have dinner soon, and also just because ice cream isn't good for focus. Let's see. Because I'm imagining a situation where you have like one hay bale on the left and two hay bales on the right that are like right next to each other, and then you want to explode in the middle of like the two widest hay bales. Um, so that way you get like maximum radius. But I'm not sure about that. Um, Come on. Okay. This problem annoying. Oh yeah. Also, the cutoff to the December 2015 contest is 800. Um, Probably because you have like all those old gold people. Because gold used to be the highest division, and all those people are like passing. Um, yeah. So I assume this one will be a slightly harder, or a slightly lower cutoff. Simply because all the OP people have already moved up to the new platinum division. Okay, let's see. Okay, wait. What if? Okay, let's modify the problem a bit. Like, what if if you're required to hit a hay bale directly? If you're required to hit a hay bale directly, then you know things. What do you know? You know that it's just going to be the minimum of the two maxes of the minimum of the two maxes. Um, yeah, so you have hay bales at like position 1, position 3, position 4, and I know maybe 1, 4, 5, and 6. Oh no, 1, 4, 5, 7. So then I believe the optimal answer for 1, 4, 5, 7 would be you blow something up at 3 with radius 2. And that covers out the 1, that covers out the 4 and the 5. And then you, no, so you want actually 1, 4, 5, 6. Yeah, so 1, 4, 5, 6 you would want to hit it at 3, which is not in between, it's not the middle of two adjacent hay bales. So that's slightly annoying. Right, because if you did hit it between two adjacent hay bales, then there's no way you can get 2 to work. Because maybe, yeah, because if you do 1.5, yeah, you wouldn't be able to hit that last cow on the right. So it's not necessarily, it's not always optimal to hit straight in between two of them. Although I would think wouldn't, if you calculate the array, like, oh no, 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 no. Okay, so here's maybe where binary search comes in, right? So you can just detect if they're equal. And we don't need to find the position that you need to blow things up. We just need to test yours. Although I think if you find the radius, you probably have to find the position anyways. So if you're given a radius, then here what you can do is you can do, I think,
Sort of like a sliding window thing, or like two pointers where the two pointers are the leftmost and the rightmost cow or bales that are exploded by the initial one, and then that way you don't need to like kind of think about anything in the middle. Wait, no, that doesn't even help. I think you can just do. I feel annoyed. This is annoying. I feel like we can just do the prefix and suffix and then just do prefix, suffix, and then axes. Right? Because if we take our example, it's like what was it? 1, 4, 5, 6, I think. And the answer was to hit it at 3. So what would be our race here? We have, okay, so the one that hit goes 0 is the leftmost, so it can explode at power 0. 5 would have to explode. If we wanted to hit both the 1 and the 5, it would have to explode at power 4. And then, no, the one at 4 would explode power 3. The one at 4 would explode. One at 4 would explode power 3. One at 5 would explode power 4. And one at 6 would explode power 7. Or no, the one at 6 could explode with the power of 5 as well, which is just like 3. No, 3 plus 1. So just be 4s all around. And then what about the other way? So 6 is going to be 0, 5 is going to be 1, 6 is going to be 2. Okay, so it would work in that situation. Wait, no, it wouldn't, because that's the explosion detonated requirement that it requires to detonate that to reach. So we actually want not that. So instead, yeah. Um, we kind of we're relying on that one. So we would want. What would we want? We would want. So yeah, we do need that sliding window of things in the range, and then we just take the ends. So basically, just place the initial hit roll in all the positions that we can try. Alright, suppose we do that then. So calculate the prefixes and the suffixes, and then do a sliding window on the range. And for citing window, we need a binary search on what the size of the window is going to be, and then just check if any of those work. I guess we can implement that.
Wait, we're already, yeah, okay. So we want, let's get the timestamp. So angry.cpp. My head hurts slightly. I think I should have slept more yesterday. I'm also rather hungry. I didn't eat much for lunch. Okay. Anyways. We're guaranteed they're ordered, right? I think, yeah. Yeah, the way it's notated makes it seem like they ordered. Although I suppose if I get wrong answer, I'll try sorting them first and see if that was the issue. Okay, so what do we need to do? We need to first off calculate the prefix and the suffix arrays. And is it ever possible for the prefix and suffix array to ever not be an integer? I don't think it is, right? Because the only ways, because like they're all whole distances apart, so there's no point in it to be an integer. So yeah. So prefix, okay, so yeah, prefix 0 is always going to be 0, so we don't need to bother editing that. Or actually, let's just to be clear, so it's either the max of the previous one plus 1, because we need to explode that one. Wait, no, not necessarily, because they could both have exploded. Wait, no, this is if we're exploding this one, though, so, wait, no, because what if they're like on a line, and then, because what if you have like one, yeah, so not necessarily plus 1. Okay, so actually, yeah, we need to figure out how we calculate our prefixes and our suffixes. I might grab something to eat. I'm rather hungry. Let's see. Okay, so we want, how do we calculate our prefixes and suffixes? Okay, so it's never possible for the prefix to go down, because it's both farther to the left and it would create weaker. Okay, so then, or farther to the right, and it would also be weaker if it's down. So it needs to be at least equal. So we need to like look back.
So we just need the rightmost. Okay, so we have like, if our previous, if like the one at I minus 1 is x, then we need to find the rightmost one that's x minus 1. Yeah, and then we do max of, or the min, do the min of the max of x and the distance to the x minus 1, and x plus, and the, or max x plus 1, and the distance to prefix maximum. Because it's like our, because our choice is either explode something large enough that it will just bypass all of like our x's until you get to x minus 1, or just explode something that will fulfill like the previous prefix condition. So we want,
let's write this out in code. Prefix I equals, so we want to choose whichever is better. And then we have either maximum of prefix I minus 1 plus 1. So this is if we just wanted to explode something large enough to get the previous prefix. A minus A minus 1. So it's our distance, or max. Okay, so now we need to keep track. Okay. The index of what? The rightmost x minus 1 value. And if there doesn't exist an x minus 1 value, then what? What do? We just don't consider. So we want to find the rightmost x minus 1. So we can just create a second pointer and increment that as we go. And so how do we do that? We would, okay, so what does it start off as? So this one, it would just be, just make it 0. So we just check. So actually, let's join these up. So just start off with that, and then so we want it to be less, and then that way, which is equal. Okay. And to just add on to her. Let's create a change min. I'm going to be lazy and just write the void change min. Okay, that should be it, I think. Let's just see here. No, still separately. Okay, now I just do the same thing. Okay, so just rename this to be her. Ah. There we go. Okay, we can just basically, and basically is copying over what I wrote earlier and just inverting things. Actual one. Okay, now let's just debug things. There. Okay, so now that that's done, we need to do our binary search on our window sizes, and then do a sliding window and see if things work or not. So, and we should never run, yes, 1 times 10 to the 9, so we should never run into, we shouldn't ever run into, like, things, what am I trying to say? We shouldn't ever run into, like, integer overflow. Yeah, because it could also be not in. Okay, so I'll just do. Pretty sure that will work. Minus the fact we haven't written a works function. And so that'll just be like our total length of the entire thing. And that way, that will cover any like issues with us dividing by 2 on an odd number. All right, so how do we do this? So we just keep 2 pointers,
One is our leftmost hay bale that is exploded after our initial explosion. One is the rightmost that's exploded after initial explosion. It's like the second round of explosions. And then we just check. What do we check? We check if the maxes +1 are actually, yes. Yeah, so it'll only work if the max is plus. Okay, so then, so how we want to do this? So we'll just advance the slow point. So we'll just always advance the fast point, and then we'll advance the slow pointer as it goes. So and then eventually they'll catch up to each other and they'll be equal. All right. So now we need to do things. What do we need to do? How do we do this? So you need to check if this works. If this specific window, what are the max? Okay, so we just do if max left slow fast, and then +1 because we need to reach there is ooh how we do this? Well, I mean, if okay, so we'll just do. Now we're fine here. And then got to return false. Okay, let's we got in 5, 8, 10, 3. Oh, they're not sorted. Imagine actually taking cues from the sample inputs. Okay, let's sort. And it crashes. No, I did not mean N. What? N was not. It's. Oh, stupid. I wrote a colon. Okay. That's worrying. Okay, that's very bad. Why? Okay, so somewhere in my binary. Okay, so first our works function is screwed up, and then my binary search function is also completely screwed up.
No, so we want the lowest one. So if it doesn't work, okay, I mean, we'll get at least one test case. Will this ever overflow? It should not. Yeah, so 2 times 10 to the minus, just barely. Small enough. Unit prefix, I should check. Okay. 2, unit 5, yeah, 6. Seven. I feel like it should be 6. Let's put this one with 6. And then let's put 8 with 5. Okay, it should be less than or equal to. Because we wanted to keep going forward. Even if it's like, doesn't match up. I don't really need to. Except, yeah, that looks all like it. And suffix, suffixes, 2. Yes, because you can put the 2 in there. 3, 5, yeah, can you go to 4? Okay. 6. The opposite one is not what you say. Okay, so let's try this, I guess. Okay, 8 out of 10. So probably missing some troll case. Okay, let's just try things. And that's wrong. All right. Yeah, because it should be. Wait, is that right? Yeah, because it could just be 0.5, and then it could just bang bang all of them. So also actually that's a small edge case I think because in this. So what if instead we make like perhaps like -1 or something? It's like, yeah, because if it's 0, I don't know, but when what is 0? Um, so still end up converting to double. Okay, so we'll just do, we'll just say, we'll convert it to double over here, just to avoid annoying things. Alright, and so now should be 1. Oh, still be 1. So I think, so the +1 should still be there for most cases, I think. Yeah, it should still be there for most of the cases. So maybe what we can just do is we'll just make pref 0. Oops. Wrong way. Let's make this -1. Or okay, how about after calculating everything? Let's look at this right answer. So maybe that was the problem? So that's certainly a problem. Nope. Alright. C-squared just doesn't have n=2 test case in here, I suppose. Or they do, and I'm just not getting it. Something like that. This is annoying. Wait, this distance is wrong. Okay, and I guess I just didn't change anything. Let's Bruh, okay, that's bad. What did I break? Wait, really? Bruh. Oh, shooting curl minus I. This curl's ahead. Wait, oh no, that's not the wrong one. Or should we? I don't know. What should we? There we go. That looks more like it. Okay. Oops. All right. Take. What is this? Take 4. That isn't. Oh, okay. Very cool. All right. That took 632. 632. It took me like 40 minutes, or 50 minutes. Yeah. So this was what? This. Binary search. This makes no sense unless you've already solved the problem. But whatever. Okay. It's not like I'm trying to write editorials here. Okay, radio contact. One of those ones lost his favorite cowbell. Oh, I remember solving this. I was solving this in the school library with the Super Ors senior who made Plat as a freshman, and he leaderboarded on Plat a couple times. But he didn't end up making camp, I think, which is very sad. But he's at MIT now, so he's like his life is good anyways. Alright, spelling timestamp. Meanwhile, I can't even spell timestamp or radio correctly. Okay. Or include. Plus H. Usually. I don't think I've typed a single line as part of this program without making a typo so far. Okay. Watch this. Whoa, no typos. You also need. So this is what? Yeah, I remember this. This is use DP on like what their current positions are. So they can either both go forward, or one of them goes forward, or the other goes forward. Okay, more free open. Oh, and also I'm expecting these problems are probably easier than this is probably much easier than the problems that I'll be looking at when we actually in like the actual contest. Both because, well, I mean I've already seen these problems before, but also just because like I think gold. I think in general, the problems just get harder as times go on, or time goes on. Times go on. Time goes on. I don't know. But yeah, I think the problems just get harder. So that's not fun, but it is what it is. So let's. Like this is basically just a standard DP, which I don't think would really show up in gold anymore. You would at least have to do some fancy trick. Okay. Okay, so actually we also need to keep track of this will be actually this will probably be a good job to do with pairs. Type def pair int. Let's just call it point. And we can also do some macros. X first. Okay. And we just make this point. East points in the positive x and north points in the positive y. Okay. So instead of this, we would do C. Oh, this needs to be an array. Let's just change that. Okay. So this is just going to be the initial positions. Position. That's all well and good. Now we just need to so they're both at 0. So it says we don't include the initial time step. So we'll just both set this to 0. And now otherwise we can either do so really we should fill DP with like some supermassive numbers. This is also actually going to be less than or equal because it's going to be after this amount of steps. Let's just do. Oh right, I don't have anything. Okay, let's just create one. Minute equals or just to avoid overflow, so let's just cut that. That'll still be plenty large. All right. Let's also do a changement because I'm lazy. If okay, so just a changement. No. So we need to do if I greater than 0. Maybe we came from I, so this will be. We'll just do DP. And then we can just add at the end. And then we'll just add like the distance at the end of these, if I'm understanding the problem correctly. Oops. Come on. Okay, this is sad. and then we have to add their current distances. So just do dist ij. I'm lazy, and we'll write a dist ij later. And then we just see out dp and m. And that is our answer. Okay, let's actually write a dist ij now. Wait, is this ever going to overflow? We do what? 1,000. There's up to 1,000 different time steps. Or 2,000, because they could each move once. So 2,000, and then the distance is going to be around. Okay, it's not actually that small. Okay, yeah, it should be small enough. Right, the square root of 8 square. Yeah, it's like not even close to 12. So, alright. And just and okay. X is oh no, X is taken. Dx is f plus I dot x minus, and then we'll square it later, so it doesn't matter if it's negative. And dy equals oops, this should be b plus, or f plus. Wait, what? Okay, yeah. Dot y minus b plus j dot y. It should be b plus dot f plus. Okay, return dx squared. Right, so this is a square of the distance. Yeah, what's dy squared? Okay, let's in. Okay, let's just copy paste. Oops, small brain moment. There we go. Okay. Radio. And it crashes. Seriously, there's an FPOS? That's just mean. Wait, is there an FPOS? It's probably with some file thingy, isn't it? Oops. Wow, that is actually so mean. Okay, let's just do FJ pos. Oh shoot, I need a okay. Let's see if I can do this. F pos, FJ pos. Yay, very cool. And then there's something about flops. Oh yeah. Why did that not? Why didn't that get caught in the thing? Maybe. Oh, I think it was because it does some DPS not declared in the scope. Oh, I should probably actually. Yeah, that might be a good idea. And this will work out. Oh yeah, I said to do 5, but this would work. This would work anyway. So there's just one, I think. Okay. And that's wrong. All right. That's very bad. And very sad. Oh, I should probably do lesson. Okay, amateur mistakes right here. Okay, wait, as if I get paid. Alright, let's do this. And it's still wrong. Okay, let's go to the next step, which is just spam print things. Oh, maybe that's why. And now it's 0. Okay. That's not correct. Let's... Okay, so we will need to end up spam printing. Equal to... I can actually type 2 pluses. Space. And then just for fanciness, let's turn all those lines together. Okay. Why? Okay, so nothing in the middle is getting. I never initially. Okay, that's I'm okay. Positive y. All right. Making positive x. And we gotta do the same thing for x. Let's just and I'm pretty sure then you can do find and replace on a certain location. It's like C. Oh, so maybe G. Okay, so let me try that again. I think I remember taking GC. I don't remember what it does, but let's. Yeah, I think so. It looks like if you just do no G, it won't check the same line twice. Okay, let's try that again. 23. Come on. This is probably the time when I should whip out some paper and actually go through the sample case. Do I want to do that though?
Yeah, probably should. All right, let's see. Paper. Got paper. Okay. New sheet of paper to scribble on. Pencil. Here's pencil. Okay. Let's just draw. Like, grid as dotted lines. Okay. This should be looking good. Let's extend it in the positives. Okay. So we start out at what? X3. X and then O. Okay. And then we go, okay, so this is just north and north. This goes north, west, west. Okay, just west a bunch. West, 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 north. Let's circle all of those. Okay, so so I really didn't need to draw most of these axes. All right. So or we could just calculate our DP table, which I think would work as well. So let's just do that. Okay, so okay, so yeah, let's start. Okay, so let's What's our first row of our DP table? First row is our DP table, only Bessie moves. Okay, so we start out with 0. And then Bessie moves up 1. So now we have x distance is 2, so squared, 4, 1. Okay, so 5. Yeah, that makes sense. And then 1 each, so 1 plus 1 is 7. And we're already off.
Did I not? I think east points in plus. Did I screw that up? No, I didn't. No, it is right. Oh, no, it's not. Didn't fully find it in the place. Okay, so I just wasted a bit of paper. Let's. Oh no, RCR and 28. Up. Let's. Video. And then I'll just
Get this paper back.
I'll use it later. Unless this fails miserably, in which that would be very sad. So let's just. Okay, that's not good. What am I doing wrong? This is not big enough, and it is not big enough. There's no way that'll overflow, right? Because whenever adding two DP states together. I guess just in case. I'm just going to be cocky and just submit anyways without compiling. There you go. All right. This is what? Us. Mark down. Wait, why am I replacing? I don't want to replace it. I think that's how things work. Alright, anyways, I suppose I'll see when I upload this to GitHub and it gets visualized. Alright, lights out. And also, probably after this, I'm going to go grab dinner. So I feel kind of hungry. So let's see. Laura John has installed a new machine. Oh, very cool. Oh, well, that's that. So after the bond. Oh no. Oh no. Oh no. This does not look good. This is going to be CompGeo, isn't it? Orange is described by simple Oh, okay. So not the exit. Had some non-exit thing. Okay. Around the perimeter, we travel a minimum distance to reach that. So if you click the lights on. Oh, interesting. Wait, I thought all these were. Yeah. Wait. What? So. So you need to somehow uniquely determine the location based on the length of this edge. Wait. Does the angle matter? Or is it just the length? Well, there's felt enough angles and edges to deduce the vertex at which she is currently located. At that point, she can either easily figure out how to get back to using the numbers to travel distance to increase over the worst case of all. Wait, what do you mean increase? Increase compared to what? Oh, then the optimal. Okay. Okay. Huh. Okay, so I think the main question here is how do you determine what is the strategy for determining whether something how you know where a vertex is? So I think it also ends only 200, so we can probably take advantage of that. And all of okay, so we can just keep track of like uh, angles and angles and edge lengths. So she always finds out the angle first, right? Yeah, because she's at an angle, so she finds out the angle first, and then she finds the length, and then finds angle, finds length, finds angle. So then um, once we can just like string hashing or something. Once that's been uh, enough, so once we run out, okay, then it should be fine. Okay, so maybe just string hashing this. Like string hashing, yeah, because you have like 2 times 10 to the 5. So like string hashing is kind of troll in this case. Maybe I'll grab dinner first and then do this problem. This problem seems mean. Okay, but actually, really quick, let's just figure out. Okay, so let's assume we somehow. Let's assume the question. Okay, so let's just figure out like the second part, right? Where once Betsy does figure out where she is, like, what's the remaining distance? So the remaining distance, is just gonna be, we can go. Wait, it's just an index of the vertice. Uh, Either you go down or you go up until you reach n. Okay, that's actually very trivial. Okay, and then then we can just do like arithmetic. Okay, let's see. Tell if that vertex is okay, since n is only 200, okay, so what we could do is we could try out each vertex, just independently, and so okay, so that's a factor of 200, and then we can, start going round. We go round, then first time. So then we need to keep track of which edges. So we need track of angles and edges. So we just need to determine once our string of angles and edges is unique.
So string hashing comes to mind, where you just hash all of the things. I know, so amazing. You just hash. So that would be what? That's O of n squared to hash all the things. So we could do this in, I think, O of n squared, which is a little overkill, but it sounds fun, so let's do it. Watch me be here. Watch me be stuck here for an hour, scratching my head. Also, my brother's playing piano, which is very, very annoying. Let's see. Lights out. Oops. Lights out. Let's see. B times stamp. Then lights out. So include with the lowercase I and no W. And spacing would be preferable. Okay. Using namespace std int n. Okay, let's hash. I want to try this out. Yeah, this will probably end badly. Okay, mods. Let's do 3 mods. We have. Oh yeah. Okay, let's long everything. Type. Oops. +7. Comma. 9 plus 9. I believe it's 1e9 plus 23. Oops, that's not how it works. 9 plus 23. I suppose. No. Let's not look it up. Let's trust here. Okay. So we have our mods. What's our base? Our base is gonna need to be some giant freaking prime number. So I don't know a large. Okay. Should I just write another quick program to just generate primes? Should I do that or should I not? Wait, does if my Python interpreter has like SymPy installed, this will be easy. Oops. Oh, it doesn't. Okay. That's very, very sad. Oh, wait, no, things? No, it's SymPy. Okay. That's sad. I guess we'll just write one really quick. We should assume, no, we assume they're all prime first. Kind of, do I want to do this? I probably don't. But I'm going to anyways. This is probably a better way to do this if I did want to do n squared. I'm breaking things. But I don't know of that better way, so let's just do it this way. Or actually, what might be better? Okay, so we just assume they're all false. So only the odd numbers might be prime. So we can actually set this up. It's one a prime, no one cares. But actually, for the sake of our thing, let's just make it not a prime. And now we just start off.
I'm actually forgetting how to write a primacy. This is sad. Plus equals 2. Plus A. Okay, I think that should run. Okay. Is this a prime number? Okay, let's just go to the beginning and know if these are primes or not. Okay, actually, let's just... I don't think... Yeah, I think my compile command makes it so... Wait, does it not? Oh, very nice, very nice. Okay. Yeah, those look good. Okay. I need like 200. I forgot about that. 200. Okay, let's just take that one. Let's close this just... Okay, so we can now... fill all of this. Alright. Instead, we do our usual free open. And obviously, in the actual contest, I wouldn't bother with the string hashing. But, I mean, like, I'm not under time pressure here. And it does seem fun to overkill a problem with n equals 200 with an n-squared solution. Hatch. Struct hatch. Okay. Well, the way I can do this will require bin cow implementation, I think. I'm probably going to use this in a set, so we want to path hash reference pointer, and we need the const here, because you can do it. Okay, there we go. So those are hashing done, I think. And then just do a hash for each length. Lengths. Okay, let's do this entire. Let's do it. Okay, now we need points. Requires 1 second. Okay. Now, I might go grab dinner and come back. Yeah, I'll probably grab dinner. This is like somewhat annoying. Okay. And so we also need to pre-compute the best. So like if you start at vertex I, what is the closest distance to the exit? So let's just do that real quick. And we already know vertex 0 is always going to be the exit, right? Or vertex 1 if we're doing one. Okay, so the first vertex is always going to be the exit. So this is 0 because it doesn't take any time to go from the exit to the exit. Let's actually rename this best. And then that way I can create a function called dist. There, nice, easy. And distances will never overflow. Yeah, because we have 10 to the 5 times 2 times 10 to the 2, which is 2 times 10 to the 7, which is good by a little. Alright, so now we need we need to go the other way as well. Okay, so we know n minus 1 is best to go the other way. think if I didn't have it in 5. Okay. Okay, that should do it. And let's choose. And join them because why not? Now we want, what do we want?
So now we need to actually calculate like all the hashes.
And actually this needs to be a multi-set. So we could probably just keep. Oh no, it doesn't matter. The whole point is that we need to. Okay, so we need then a multi-set, I think. Or we could just do a count. That would be the easiest way. Okay, so let's just start. So we don't want to start at 0 because if you're at 0, you're just done. So we need to go in clockwise order. And I think the keep it in clockwise order. Yeah. Okay. So our hash, it just starts out as nothing. Okay, so now we need to determine if the angle is 90 or 120 or what the angle is. Wait, can there be an angle that's like 180 where it's just like a straight line? Is that allowed? No, it's I just alternate. Okay, so it has to be a 180 or 90 or 120. So we can figure that out. Is the angle 90 or 120? Should I just do cross products? Maybe a good idea to see if I can still remember cross products, which I can't. I can't remember cross products. this is turning out to be a little more trouble than I thought it would be. Um, okay. Let's see, do I look up CCW or not? Or do I just write some sort of thing that will just bash? Um, okay, I remember that much. Um, so something about slopes. If the slope if the slope is larger, then it's clockwise. If the slope is smaller, it's counterclockwise. Right? Yeah, if I just visualize it. The slope is larger. Okay, so the slope is what? Y over X. So if I wanted the slope of the first one, so it's actually the slope of the second, or like the original thing. Uh, I'm not so sure about this anymore. Wait, slope's not even right because depending on the positive, negative. Wait, oh no. So if it's slope is less than. I am so confused. Maybe it's not. Maybe it's from B to C. The slopes of the two lines. Should I just look this up? I'm just gonna look this up. Let's take the first one. Okay, so dx is integers. Okay, so dx1 times dx2. So if it's greater than the counterclockwise. The second one is greater than the counterclockwise. Okay, but why? Dx1. So if the first slope is less, then it's counterclockwise, is what this is saying. So first slope is less. Let's take out a slope. Yeah, the one is the same. Not counterclockwise. Let's get a slope that's negative. So if you have a slope that's negative, it means so why? What is this? They just didn't find a slope, so yeah, they do. So slope 2 is greater than slope 1. And I can get it for like the positive quadrant, but I don't. Okay. Let's get some paper. Sad thing is, I learned this in A-Star like 2 weeks ago, or 3 weeks ago, and I've already forgotten how this works. This is counterclockwise. Alright, so we have. And obviously, you won't be able to see what I'm doing because I'm writing on paper, but it sucks for you, I guess. Okay, let's see. So we have. Well, I'm going to do my A minus B because it's just what I have. So let's just stick with that. And everything goes negative. And so negative. So this is the same anyway. So negative times negative.
So we would have a vector of negative -3, and we'd have a vector of 2, -4. And so it's the same if we take -4 and that does line up, so it should be complex, and it is. Okay. It would still be the other way around. Oh, so you do have negatives, and just works out better. Oh, so it's just so the cross product makes it so that the negative is multiplied on one of them. Okay, that sort of makes sense. Okay, so it's kind of otherwise bad things are happening. You just say false. Okay. So straight off the bat, I want to add angle I, and then maybe this. Okay, so it's not possible that you can uniquely determine based on angle. Might as well add it anyways. So let's. We don't really need the MN since we're already. Since we already have the length inside the hash, so there's no need. Okay, so we go. There. So that would add all of the hashes in. Or no, it wouldn't. It would just add one hash, one supermassive hash in. There you go. That will add all the hashes in. Okay, so our answer starts off 0 because first case is not a 1. And then we would want just assume you start from a certain index, and then okay, so basically just do the same thing. So actually, it's just like just copy paste, except this time we don't want to add to our hash. Dict. And okay, let's get rid of this since it's literally not possible. You can't uniquely determine based on just one angle, since there's always going to be, if there's one 270, well, actually no, that's not true. There might be, yes, like you could have one 270-degree angle. Right? Yeah, you could. Yeah, so that would work technically still. So
you find if the count if okay, and the hat it should always be in there since um, we're uh, we're just following the same process. Okay, so we just okay. It's here if so that means we found a unique one. Then we can do then it will just be answer. So the distance we end up traveling, which would be rest j plus the distance we travel to get to j minus the distance I. That's not this way. The answer. Except we actually spell things correctly. What? Okay. Good actually, okay. That's bad. Oh, right. That is. This is the right answer. I don't know if that means much though. I guess we'll try it. Okay, and then hopefully this works, and then I can go eat dinner. And dinner depends on the success on my USACO submissions. Okay, that's not good. That's very bad. That is very bad. Okay, wait. I'm not sure what happens if I actually negative. What if this one goes negative? Oh wait. So actually, oh sure, I need to find a new base then. And oh god damn it! I need to rewrite my website. Okay, that's plenty big. I mean, like, it took me a few minutes to generate primes up to, like, 10 to the 9, so this should only take, like, a second or so. roots. Okay, let's do that again. Now I need to find, so should we do like, six digits. Okay, let's take. Wait, that's not prime. What? Six. That's not good. How did that get prime? Oh. Oh. Okay, so should be enough. Oh, nine. Let's just see this code. Alright, let's see if this works. It probably won't, but too bad. Nope. So very sad. Okay, let's see. Oh wait, we need to stop. Maybe, okay, so we also have gone all the way around. In this case, it would be all the way around. Oh no, we need to curve this. We need to add the last one where we go to the end. Oh, we already, yeah, okay, so we just do. Okay, it's a big mistake right there. Let's try again. It'll probably still fail everything. Okay, yeah, it's not. Oh, okay, there we go, there we go, there we go. Very cool. Okay. Lights out. That took me an hour. This is technically n squared log. Okay, I'll probably take a break now. If I didn't once I actually finish my break. And I'll probably just stop the recording just because, like, nothing's going to happen while I'm eating dinner. I'm actually just go, like, watch something, just, like, relax. Yeah, this is n squared log, n squared. Okay, yeah. I think, yeah, alright, and then, what is that? Alright, very cool. Also had to look up, oh wait, yeah, I should also do. Okay, and I'll probably just stop the recording here. Actually, I should probably take a look at the editorials, and just make sure, like, I didn't miss something or get lucky or whatever. Okay, let's just take a look at this first three. High card, low card. First thing. Yeah, so maybe let's do what I did. Yeah, jeez, this is probably you can do it. I mean, okay. I guess. Yeah, so just do Java. Next icon. Yeah, so you can just do the things. Do all the things. DP, the Dijkstra. Why would you run a Dijkstra? Oh, I see. Okay. Really, I would say the second is easier because otherwise you have to like do annoying things where you figure out like you have to create separate edges for the purple tiles, and that's just annoying. So I would say the second one's actually probably easier. And then yeah, imagine doing state packing and not just having a 4D array. Yeah, this is like longer and it seems more annoying to do. Alright. Okay, so that's the first one. Let's go back. Okay. Left hand scan. Yeah, so we just do what I did. Okay, yes, that's what I did. Remarkably concise. Remarkably concise. Is this remarkably concise? Wait, then what? Best crossover point. Wait, so was my sliding window thing not necessary? Oh, interesting. So we do 2 pointers, but from out to in. Imagine not just converting things to doubles. Okay, wait. Okay. Yeah, this is what I did. Alright. Cool. Okay. Dynamic time warping problem. The heck? Similarity between two controls. Okay, that sounds too big brain for me. Like the error functions. Therefore, wait, are dynamic time warping problems like DP problems or something? Okay, anyways, imagine not type def. Okay. Yeah, just compute and choose Bessie, and then do DP. No, we don't want to do the. Okay, yep. That's basically what I did, except I did it iteratively, which is probably faster, so ha ha ha. That's not okay. It's oh, cool. So hashes were considered. Wait, so what is? This is definitely shorter than my solution. Oh, that's why also slower. Okay, that's cool. Oh, interesting. So the cross product was necessary no matter how I did it. Okay, that's interesting. 600 feels bad, man. Yeah, that's kind of what I expect, right? Because all the OP people went up in first contest. All right, I'll probably stop here and go eat dinner, given that it is basically 8 p.m. And also, I might actually just stop here for the day because I have to study for a chemistry test tomorrow. And I have like 92 in chem right now, so I need to not screw up the test. Which actually shouldn't be too hard. I got an 86 on the first test, so I just need to like not get worse than an 86, and I'll be fine. Okay, that's off topic though. Or too bad. I'm just going to just yell random stuff about my life, since no one watches these anyways. I also have an Algebra 2 trig test tomorrow, but hopefully that shouldn't be too bad. It's just like, can you remember two formulas? And if you can, then you're good. Also graphing things, but those are like pretty trivial. Yeah. And then I don't know what the heck we're doing in Chinese, but I don't really care either. So yeah, okay, I'm gonna go eat now.